Welcome, everybody, to episode number 3 of the Multi-Cloud Expedition. So this is a series in which we recap, or we look through all the different challenges of the multi-cloud environment that our customers are facing. And then we tackle those one by one in a series of episodes leading up to VMware Explore. So to kick off this episode, let's go ahead and level set on the customer journey that many of you are involved in right now. So when we think about the history of the multi-cloud, really what started out was customers began with cloud first. And they said, okay, you know what? We want to develop modern applications. We're going to go ahead and work with a hyperscaler, and we're going to go into this great, cloud first world. And that's kind of that upswing that you see there in the visual. Then as things got more complicated, right? New clouds started popping up. It's the concept of sovereign clouds, the concept of a private cloud, the concept of using multiple hyperscalers. And customers have found themselves in cloud chaos. So when VMware says, how we define the multi-cloud is the hyperscalers, as well as the sovereign clouds, as well as on-prem, as well as the edge, because all of these different clouds are needed in one way, shape, or form in order to accomplish the business outcomes that customers are looking to do. Now, using those, right, in a cloud smart way is what the goal is, right? So the right cloud for the right application at the right time. And VMware Cross Cloud Services has the ability to help customers tackle those multi-cloud challenges in order to get to cloud smart. All right. Now, since this is a series and we've got multiple different episodes, one approximately every different month, let me recap the last 2 episodes, episode 1 and episode 2, in case you missed it. Those are both available on demand. In episode 1, the challenges that we tackled were really around increasing developer velocity, right? This is around how can customers use the multi-cloud environment to increase that application development velocity. And we covered many different areas, from helping with people and process improvements to using templates and accelerators to do more rapid application development, as well as looking at how do you improve that secure pipeline of application production. Then in episode 2, we went ahead and covered the fundamentals of cost and observability in the multi-cloud. So when you've got a multi-cloud environment with multiple different applications, then how do you just get the basics? How do you know how much money is being spent? How do you know what the applications are actually doing and be able to observe them? And so we deep dove with subject matter experts from VMware into both of those different topics. So those are both available on demand. So check them out. All right. That's a perfect segue then into what we're going to cover today. So today we're going to build upon that episode 2, and now look at in this episode, how do we get deeper into governance of a multi-cloud environment? And we're going to tackle that entire life cycle, right? Standardizing policies, then monitoring those policies, ensuring that they're enforced. From there, we're going to look at a little bit of threat detection. Then we're going to move into a very important topic after that and look at securing, how do we secure these modern applications, which is very different than how applications were secured previously when they were monolith, right? Throughout the episode, this is live, so encourage folks to throw their questions into the chat. And what we'll do is we will group all those questions together. At the end, we'll have both of our experts on, and both of our experts will answer those questions. So if you have questions as we go through the material, a lot of this does get pretty detailed. We'll go through not only the challenge, but then we'll also go through the product that will help solve that challenge. Feel free to throw your questions in there, and we'll again grab those at the end for the Q&A. With that, I wanted to welcome an expert, one of our subject matter experts from VMware, Jyoti Sharma, who has got an incredible amount of expertise, specifically in all things governance as well as infrastructure policies. So Jyoti, welcome to the show. Tell us a little bit about your background.
Hello, everyone. I'm Jyoti Sharma, and I'm a product marketing manager for a cloud security and compliance solution. It's called VMware Aria Automation for secure clouds, and I'm also working on a multi-cloud governance and policy management service, which is called VMware Aria Guardrails.
All right. And so one of the places we wanted to start was we're talking about governance and talking about this governance lifecycle. Tell us a little bit about the problems that you see customers have when it comes to the multi-cloud environment and tackling this governance topic.
Sure. So I want to take a step back and really talk about the situation in which the central teams, such as operations and security, often find themselves. Um, on one hand, there's adoption of public cloud, and they're able to quickly deploy software services. But these central teams are tasked with ensuring that the costs are regulated, the configurations are secure, and the performance is optimized. And that's in the landscape of vast number of accounts and services that are spread across multi-cloud environments. They're also supporting multiple developer teams, which are continuously building applications. So it's very easy to make mistakes. To secure configurations and ensure compliance across the entire application lifecycle, they need to have both a preventative and a detective approach. But I want to talk a little bit more about the preventative approach, which is basically that they configure these policies onto the accounts before handing them to the developers when they'll start building applications. But for most teams, these processes are really manual, and it involves use of several tools that don't talk to each other, and that makes standardization very difficult for these teams. So eventually, they end up with inconsistently applied policies across the accounts.
So let's back up a little bit. And from the audience standpoint, right? Governance and security policies have been around for a long time. Obviously, they're implemented and well understood when it comes to, I'd say, more on-premises type of environments. Now, when customers, start to think about the multi-cloud, right? And where do they kind of begin to run into that problem? Where have you seen scenarios? I think one we were talking about before was mergers and acquisitions, right? The idea that, okay, we just acquired this company, and it turns out that now, how do we know if this policy or this type of policy is in effect or not in effect? Maybe you could talk a little bit more about that.
Sure. So there are different scenarios. They could be, you could have inherited some accounts or infrastructure because of a merger or acquisition. It is also possible that when you start migrating your workloads to the cloud, you typically start with just a few accounts, like for example, 5 accounts or 10 accounts, and when you start out and start building applications, and some of these manual processes and the DIY tools actually work at that level. But as you start adding more services, you start adding more accounts, and your cloud footprint starts to grow, you're not able to consistently apply these policies and scale those governance standards going forward. So so from a long-term perspective, these processes don't work.
So I think that word scale is what's super important here, right? It's that, okay, to have the company really advance its capabilities and do it at scale, then it needs a way to apply all these things consistently. And something even as simple as just the password policy, right? If there's
Exactly.
a requirement in order to make it a certain number of days before it expires, or the password length. And I think that's going to be the first thing we're going to show is how
Yeah.
we can help apply a policy to an environment that's been standardized. So let's go ahead and roll that first demo.
Here I am in the Guardrails user interface built on top of VMware Aria Hub. You can see that I have one account connected already into my Guardrails environment. This is a AWS account, and I'm going to start by applying a new policy template. And so what I can do is I can click this Apply Guardrails button here, and this is going to take me to the wizard to apply a new template. Very first off, I can choose which account to apply to. I can choose my AWS account or an Azure subscription. In this case, I'm going to choose my AWS account, and I'll click Next. And from here, I can choose what template to actually apply. I can look at the library templates that VMware Aria Guardrails provides to me out of the box. We have different types of templates for configuration policies, security policies, cost policies, so on and so forth. And today I'm going to use this AWS IAM password policy. This ensures that all IAM users have a strong password. And what this means, as we look into the template, we can see this means that we can require symbols in the passwords, a minimum password length, numbers, uppercase and lowercase characters, as well as other configurations that IAM allows us to do with passwords, such as allowing users to change their password, expiring passwords, setting a maximum age for a password, preventing reuse of passwords, as well as setting hard expiries. And so in the template, I can see what Guardrails will do. It will essentially create this IAM policy using the parameters that I have defined. And if I scroll down, I can see that Guardrails is going to ensure that that policy is always present in the product, in my AWS account. And so I can click yes and import that into my curated templates. I can change the name of the template if I want to something more customizable. So for example, strong password policy, and I can change the description if I want as well. I'm going to choose a project to import that into and click finish. And so now I see it in my curated templates here. Again, from here I can see the template, what it actually looks like as code. I can close that out, can click it and go to next. And now I'm going to actually define what my policy should look like. So all my input parameters are here that are going to define this policy. So first off, I'm going to give this a name that we're going to apply it as. So this again will be strong password policy. I have my different parameters to say what I want to require as part of my passwords. So for example, perhaps I don't want to require numbers. I can set a password length as a maximum and a minimum as well. So let's say I don't want a password to be more than 30 characters long, but I want it to be more than 20. I will leave all the other default parameters for now, but you can always change them. You can click validate and then click next. And then I'm going to click monitor this guardrail, which essentially is going to tell Guardrails to ensure that this password policy is always in effect in my account. And if it's not, show me a drift alert. I can apply this policy, apply this guardrail, and it's going to do that.
All right, so we definitely got into the nuts and bolts of specific character length and applying that password policy. And to many folks, they might think, well, that's kind of basic, right? That's just a basic policy. The tough part is not doing it in one place, right? The benefit of VMware Cross-Cloud Services is to be able to say, look, here is the standardized policy, especially as we have, as we scale the resources that are being used, and apply it consistently, right, across all of those different environments. It's a lot harder than it looks to do this part, when you do it across multiple different clouds. So I don't know if you have any thoughts on that.
Yeah, so the benefit of having the cloud definitions templatized is think about it from the point of view of like a central admin person who's actually applying these policies to the accounts and handing it over to multiple developer teams. So all they need to do is just define all of these policies into a template and then stamp that template to every account. And that makes sure that the set of policies that you want to be enforced for that account are already there and they're applied in a consistent manner.
Mm-hmm. So basic blocking and tackling, but very important and hard to do in a multi-cloud environment. Okay, we've got our policy now, right? We've got it stamped out. And is everything good at this point? So, or what do we have to do next to make sure that it is enforced?
Yeah, so the very nature of the cloud infrastructure is super dynamic. So once these accounts are handed over to the developers, they start building applications, and that's when there are changes that are going to happen to the resources and the configurations. And it's possible that some of these applied policies, just because of the configurations have changed, there might be violations to these policies. So you need to be also able to continuously detect if there was a change and to bring it back to the desired state that you want. So the product also helps to continuously detect by such violations by applying an event-driven kind of a mechanism.
And the word, I like the word that we use for this, drift. I always thought drift was like, at least as my teenager describes it, it's drifting a car, but the same thing happens in the cloud. The policies just kind of, once they're, although we've got the recommendations and the stamped out, right? Before you know it, it is so dynamic that they drift slightly away from it. So this
Yep.
next demo is going to say, show us how to detect that drift. Let's go ahead and run it.
That I have applied my template and my policy included in the template, I can go and see in my account through Guardrails if the policy is actually being applied or not. And so I can go into the findings tab here and I can see a list of all my findings across all my accounts. And on the left tab here, I can actually traverse through my different accounts. In this case, I only have one account connected, but if you had multiple organizational units with different child accounts or member accounts, you would see them all listed down here in a hierarchy. And so if I go into my specific AWS account, you can see I have different types of findings, and you can see I have a finding for that password policy that I just enforced. If I go into Guardrails, I can see what the policy is that I was trying to enforce, which was enforcing strong passwords, as we talked about. You could see the result, which is what Guardrails found to be the problem and what it would potentially do if it wanted to remediate it. And so Guardrails offers a suggestion of what you should do in this case. You need to update that password policy. And I can go into this view difference and actually see what the problem is. So on the left is the current state of your account. And in this case, this is what the current password policy is in your account. On the right here, you have your desired state. This is what you are trying to get to, and this is from the template that you just enforced. And so you can see we have a few discrepancies that we need to go and fix. So namely, we need to ensure that the required numbers, we had set it to false, so we need to go and change that. The maximum password age needs to be set to 30, minimum password length of 20 characters, and password reuse prevention. The past 24 passwords can't be reused as opposed to just 3. And so if I go into my IAM console of my AWS account, I can see that all of the current values are displayed here, which is what Guardrails is calling out as a drift. So I can change some of these, namely the password minimum length we said should be 20 characters. We said we're not going to require any numbers. The password expiration is going to be a maximum of 30 days instead of 90. And lastly, we're going to disallow the reuse of the past 24 passwords. And I can save this change and set this as a custom policy, and you can see that my password requirements are now updated. If I go back into Guardrails, I can see if this has been resolved or not. Simply, I can go into this desired state and I can monitor this immediately, basically telling Guardrails to go and check that this has been fixed. And so that is going to run. I can go into the accounts associated desired states here. These are the templates that are being applied against the environment, and I can see essentially what the results of each desired state is. Okay, so a few minutes has elapsed. Essentially, we were waiting for the last run of the desired state to update. What this means is now I can go into the view results and you can see that Guardrails has checked for the enforcement of this template and the policy twice. And so this is the first run that we were looking at. This is what we initially saw as a finding because we had the difference, right, of a few parameters. That was the old state, and this was what we wanted it to be. And so now I ran that desired state again to see, okay, figure out if there is a drift. And now Guardrails is saying there is no findings, which is good. Essentially, this means that there's nothing different between the current state of the environment as well as what we have defined in our template. And I can go into the view diff and nothing will show. This is because everything remains the same, and so there's nothing to call out as a difference. And so that's how you can see findings. This was a very simplified example through Guardrails.
It's super impressive, right? To be able to do that. We're just showing it on one cloud, right? But we've got the ability to help customers do that across multiple clouds, and they can do that at any time. So there could be a lot of different scenarios. One scenario could we go back to we've just acquired a company and now we're merging the IT, and we want to go out and find out, does this policy that we have, do they have the same policy? And just boom, right through that UI, you apply it, you see it out there, then you see the differences entirely across there. You even see the history of it. So I think it's a really fantastic demonstration of the power of being able to control that cloud chaos across this one policy. So super important. We covered monitoring policies. Then the next thing is, what are some of the risks, right, that customers are encountering? And maybe you could set up the next demo a little bit, the context for it.
Sure. So, like we were talking about changes in these configurations in the cloud environments, right? So there's developers deploying code and continuously, and like I said, it's easy to make mistakes, and these are always mostly your configuration mistakes. So you want to be able to detect whether these configurations mistakes are leading to create a risky situation, which an attacker can exploit. And you want to be able to continuously monitor those risks and also ensure that there is compliance to some of the industry benchmarks. And this is particularly challenging, of course, because of the ephemeral nature of the cloud resources. And I want to talk a little bit also about different techniques and different kinds of risks, because you have misconfigurations, and typically you have a different tool for identifying what the misconfigurations are, or to figure out like who has access to resources in the cloud environment, so that you can manage the access permissions, or you have threat data. But the customers need a more integrated approach where they can see all of these risks for certain resources together. And this is where I want to introduce VMware Aria Automation for Secure Clouds. It's a native cloud security and compliance platform that helps to continuously monitor configuration risk, whether it's a misconfiguration, whether you want to identify access permissions, IAM policies. And it also allows you to integrate with other tools, for example, Amazon Guard Duty or Amazon Inspector, and bring in data so that you get that central view and a consolidated view of all the violations or all the risk associated with the resource.
Mm-hmm. Yeah, it's a great setup for thinking about in that multi-cloud environment, right? Then how do you kind of do some of the threat detection pieces when you begin to see that threat? And that's what we're going to see in this next demo. So let's go ahead and roll the next demo.
VMware Aria Automation for Secure Clouds to investigate an incident. Here I have an alert that is coming from Aria Automation for Secure Clouds, which states that one of my S3 buckets has logging not enabled. This is really concerning for me, since we have a policy that every single S3 bucket should have logging enabled, and if someone disabled it, I definitely want to know what's going on there. Probably it's some user is compromised or something. So I'm going to click on View Details and find out more. This is going to take me to the VMware Aria Automation for Secure Clouds product, and here I can, on the right side here, I can find more information about what triggered this alert. In this case, this rule here, S3 logging should be enabled. But first, what is this S3 bucket? I see here that we have whole 14 open findings. And probably the most concerning ones are with the highest risk score. We have a discovery S3 Tor IP caller, which means that someone is trying to execute API calls using a Tor IP client. The more concerning one is that someone actually succeeded to execute API calls with Tor IP. And we have even anomalous behavior that someone deleted objects from that bucket. So that's really interesting.
Here we're really thinking about, and we're progressing through the life cycle of governance, right? Because we started out talking about those policies, then looking at policy drift, and now we're looking at policy, actual exceptions, things that are going outside of that. Logging being turned off, a very popular, or not very popular, very common, I guess it'd be a common signature that something nefarious is really going on, right? And so being able to see that, again, it's one thing to do it in a single cloud. The challenge is being able to see that anomaly across your entire environment. This is what's super challenging for customers. And I think is that, and you talk to different customers, is that one of the things that they surface often?
Yeah, so one of the things that's also there is that there are different resource models for different clouds, and they also want to be able to monitor their inventory and look at the changes. So like I was talking about continuous monitoring, right? So one thing that the platform does really well is that it models the entire multi-cloud environment into a single place, which essentially means that it brings the cloud inventory data together with the resource relationships. And now this is also enriched with entitlement information. And doing that for different clouds is actually centralizing all of that information in one place, because otherwise going and managing these for each of their cloud accounts is really challenging. And then, from a risk perspective, the service provides about 1,200 inbuilt rules across public clouds, AWS, Azure, and GCP. And then the service applies these benchmarks and best practices to this data model. And that actually surfaces the risks that are occurring in the cloud environment. So it makes investigation easier. And it actually makes that brings that visibility of all the risks that you can see in your multi-cloud environment.
Yeah, tying back to what we just saw with K. Constantin, right? This possible, violator, or something's going on with their account. Why not just terminate at that point? Why not just kind of say, okay, you're done? Or do we have enough info to even say that?
Yeah, so another thing here is that you want to be able to investigate like what that user is doing, and also whether that's a necessary action or not, and then go down. So that's the kind of investigation that you need to carry out. One challenge that customers have is that a lot of times these central teams are trying to enforce these best practices, but at the same time they have very little deployment context, or what the developers are doing in the cloud. So they want to be able to get the right information about, like, for example, this user that we are talking about, like who is this user, what is the actions they are taking, and also if there is a misconfiguration that's arising because of their actions, then they need to be notified about it. But you need to be able to run that investigation. And what the product does really well is that it brings together all of that deployment context of what changes happened, how the inventory changed, the activity logs get updated, so that the central teams can carry out that investigation before they decide that whether they want to terminate access or not.
Yeah, I think the point you just made about that deployment context is what the person who's getting the alert doesn't have the visibility into, right? And so without that deployment context, then it's not prudent, perhaps, to go ahead and cut access immediately, because maybe there's just, as you said, a misconfiguration. Maybe it's not actually malicious, and and who knows the other privileges that could cascade to. So I think on this next demo, we're going to go ahead and look at a little bit more detail into that investigation and how someone can root out is this a bad actor or what's going on? What's some more forensics around what's going on? So let's go ahead and roll that.
Probably the first thing that I want to check is the activity log. What happened to that bucket? Here we can see all the actions that were executed against this S3 bucket. In this particular case, the most recent one is put bucket logging. This is probably the action that triggered the alert that I have on my email. And it was performed by a user, K. Constantine. If I want to have more information about this event, if you click on Vue.json, you will have all the context. In fact, here is the full Cloud Shell in JSON for this event, so you don't need to log in the AWS console. You have all the information here in VMware Aria Automation for secure clouds. The next step we have here is account details. If you are managing a large environment with a lot of AWS accounts, sometimes it's quite challenging to find who is responsible for this account, who you can contact in order to investigate further and stuff. Here you have it just on one click. Here we have a resource overview tab, which can tell us what are the configurations of that particular resource, in this case S3 bucket. And as you can see here, logging enabled is false, so definitely someone disabled the logging, and we want to know what happened.
So the logging was disabled, and then K. Constantine, so we got a little bit more information. And I think actually the next one, the last one, that's going to tell us the demo for kind of going into details of that, correct?
Yeah. So I just wanted to add here that, I mean, at this point, you want to see, that there's some suspicious activity that's happening. So typically you want to go and see that, okay, who this user is, what other resources does this user has access to? Because one major challenge is that typically in multi-account environments, there are several developer teams that are given access to resources. And these users may have several paths that they can take to access a resource through roles and different policies. And as a central team that's managing these permissions so that the right users have access to the right resources, they need to have the visibility into the users and what are the different paths that they can take to access some of these resources so that they can follow the best practices. Like, for example, if there are certain policies and actions that are not used, then the best practice is just to revoke them. But how do you know which ones you want to manage, how you want to manage them? Do you want to continue having access to these resources? And I think the next one kind of ties more into, like, how do you get visibility into cloud entitlements for users?
Yeah, let's go ahead and run that one.
As you can see, all the recent actions are triggered by this particular user, K. Constantine. So let's go on the entitlements tab, which will show us which are the principals that have access to that object. In this case, 13 users and 28 roles. If I click on view entitlements, I will be taken to a screen which shows us detailed information about those principals, users, and roles. But we're interested in this particular one, K. Constantine, that performed the call that triggered this alert. And as you can see here, the access key age for that user is 300 days old, really concerning, violating a lot of policies as well. The password age, this user also has console access, and his password was unchanged for a year and a half almost. This is really concerning. It has a lot of findings. If I click on findings, I will be taken to a screen which will give us detailed information about the findings. Some of those are really severe, but we are not going to focus on that. Let's go back and click on that possibly compromised user and evaluate what is the access that this user has to over that S3 bucket. So we are taken to this nice little graph here. We can see that this user is entitled to assume 3 roles, and obviously has direct access to some policies that are directly attached to that user, which grant him permissions on that bucket. On the right side here, we can see what exactly are those permissions and which are the policies that are granting them. For example, here we have delete access point policy. This action can be used for exposing resources. If you delete the access point policy for that S3 bucket, it can lead to exposing resources, and this action is granted by AWS administrator access policies. You can find out the name of the policies as well here. If you expand by double clicking on entitlements, you will see the names of the policies. And this particular one, if I click on it, is the AWS managed AWS administrator access policy. This is really concerning, since it basically makes this user an administrator. And as you can see here, this user has this arrow here, means that this user has directly attached this policy. But even if you, but on top of that, he can basically assume a role that will again allow him to get access to this AWS administrator access policy. And it's not even one role, and there are 3 roles that this user can assume: admin, I make no sense, and ASD, that are basically granting access to that administrator access policy. That's really concerning. So let's go back. If I click on the user again, I will see all the effective permissions combined for all those 3 policies that are granting actions over that S3 bucket.
Yeah, this again, when you see it visually, is incredibly impressive because, and I think this is a lot of the point of this show is to show how the solution actually works. The other way to figure this out is, and I think you had described it before, is flat files. Isn't that right? Just text
Yes.
files?
Yeah, so if you don't have these kind of visibility where, so we saw in this example, right, that you were able to drill down to, who took this action that led to a misconfiguration. And then you went into seeing that, okay, this user has a lot of findings associated with them, which means that they are making a lot of configuration mistakes. And then you saw that they have administrator access. So the platform is actually bringing in a lot of information. It's bringing those findings, associating it with the user, because of whose actions, those findings you can see in the platform, and then what kind of access they have. So at this point, you have enough information to decide that maybe do they really need access, administrator level access, and to your question about terminating access. So now the central team has enough information to be able to decide whether they want to terminate access for this user, and they have enough data as well.
And going back to the complexity of the multi-cloud, thinking about, well, if Kay Constantine was not so diligent in managing their processes and configurations, perhaps they've done the same thing in another cloud, other than being able to even go investigate that and be proactive in that sense. So for audience members that are parsing through text files to try to figure out what the permissions are, as well as inherited permissions, and what resources are then tied to those, our product very much can help with that. So with that, Jyoti, thank you very much for joining us for this first part of the show. We are going to bring you back for the end of the show. And I know there's been a number of questions that have been posed to the in the chat. So when we bring you back, we'll bring those together, and then we will have you answer a few of those. So thank you very much, and we'll see you a little bit later. All right, and now we're going to move. So we talked a lot about the governance lifecycle. So from creating policies to then watching policy drift to then threat detection. And now we're going to move into the evolution of applications in the multi-cloud environment and the security implications, as well as how to deal with those security implications and risks in that multi-cloud environment. So joining me, another subject matter expert from VMware. Please welcome Rick. Hey, Rick.
Hey, Alexander. How are you?
I'm doing well. It's an exciting show, so happy to have you here. And tell us a little bit about your background and your expertise before we get into the details of application security.
Sure. So I'm a longtime VMware veteran. Been here for about 11 years, and in my current role, what I do is really help our customers evaluate our Tanzu solutions and primarily Tanzu Service Mesh, which we're going to be discussing today.
All right. And beforehand, you and I had talked quite a bit about just
Yeah.
it's a bit of a history, right?
Yes.
When it comes to how applications were built before, how they were secured before, and then how they're secured now. So maybe walk us through a little bit. What did the old world look like? And then progress us through to some of the new world.
Yeah. So if we can put up that visual, we kind of started off with kind of a monolith application, which really kind of, had all its business logic in a couple of components. And how applications have evolved, specifically in the modern world, is we're seeing, these monoliths being broken up into these individual, what we call microservices, where we decouple the business logic into these individual units. And there's obviously benefits in doing that. We're able to iterate much quicker, and use different technologies for these individual services. However, we've seen a proliferation of complexity now, and so with that complexity, we need to look at better ways and different ways of how we protect these applications, specifically looking at how we may want to distribute these applications across multiple clouds.
So in the old in I would say old world, the simple world, because it certainly wasn't simple and isn't simple today. Database, right? You've got database, you've got tables, and they were all not all in one place, but probably the majority of it would be housed in a single place, and then an application layer. Now, what you're describing here is taking that database and dividing it up. It could be in 2 microservices, or it could be in 15, right? And those could even be across different clouds.
Yeah. Yeah, definitely. We're seeing, with multi-cloud and cloud in general, is these, databases or applications in general just being distributed horizontally, right? So that we don't have a single point of failure. We have this level of resiliency now, right? So there's all these benefits, with regards to being able to distribute these applications. But how do we secure these applications now? I mean, before, in the past, we would look at the IP address as an example, as that identity for a component in our application. Although these microservices do have IP addresses, they're ephemeral, right? They're constantly changing. So we have to look at different levels of abstraction on how we start to protect our application. And it's obviously important to protect it from a north-south standpoint, but also very important to protect our application from an east-west perspective and to achieve that kind of zero trust security and compliance model.
Yeah, that east-west protection definitely easier inside of the data center, right? Because, like you said, tied to an IP address that you controlled, you knew. Not the case when it gets broken into many different parts in that multi-cloud. So let's just, if we kind of talk through an example of, let's say a single component or resource being broken into 10, then maybe being broken in again for application development purposes, the complexity starts to get pretty darn difficult, right? How do you even know that the right information is going from one resource to another? That's the super big challenge.
Yeah, and so we need to, we want to use context like the service as an example, as a means to be able to apply policy, but not only the service itself, but kind of look deeper down and at the APIs that service may be exposing as well, right? So, we often see now that the API really is the new endpoint that needs to be protected.
Mhm. And we've got the demo that's going to talk through kind of the big components, right?
Yeah.
Of where you start. So maybe if you want to set up a little bit of context before the demo kicks off.
Yeah. So in this first demo, what we're going to see is exactly what we just discussed. A highly distributed application based on microservices that span, multiple Kubernetes clusters across multiple clouds, and we want to be able to, protect this application and be able to define a zero trust model that basically states only these services are allowed to speak to, one another. All other communication is denied, and do so not only a single cluster, but as, this, again, application is distributed across multiple Kubernetes clusters across multiple clouds.
Yeah, and this is where a picture, in this case, a video is worth 1,000 words.
Absolutely.
Because we're going to look right now to see a topology of that complexity you've described, and then we can work back after that on the different points and how there's challenges in securing it. So let's go ahead and roll the demo for Tanzu Service Mesh.
Tanzu Service Mesh, and we're looking at our multi-cloud application from the global namespace construct. The global namespace is a logical construct that's unique to Tanzu Service Mesh that allows us to group together services that span multiple Kubernetes clusters that may be spanning multiple clouds. So in this case, these color boxes represent Kubernetes clusters. And so you can see that I have 3 clusters that make up this application. 2 of them are running in Azure. I have one in Azure East and another in Azure West running our shopping service. And all our backend services that make up the application are running in Google. Now, when we enable the global namespace allows these services to discover and communicate to one another as if they were in a single cluster. All communication between the services are MTLS encrypted. And we enable this by simply installing the mesh into the cluster and enabling the global namespace construct. There's no additional coding required. Developers don't have to recode in order to enable this capability. Now, if you look at the application from a user experience standpoint, it's a very simple storefront for sporting goods. You can see that I can browse the catalog and add items to my catalog and so on and so forth. Now, you can see that this particular application is active. It's actually right now I'm running hitting the application from Azure East. You can see that I have 2 instances of shopping, one in East and one in West. So currently I'm coming in from Azure East. Now, when we're looking at the application from a security standpoint, it's obviously important to protect the application from a north-south standpoint, but just as important to protect the application from an east-west perspective as well. And so if I switch over here to security, we can see the access control policies that have been enabled on this particular application that basically explicitly specify what communication is allowed. So all these communication paths are explicitly enabled. Any other communication between services would be automatically denied. Now, you can see that by applying or creating the policy, it doesn't matter where the services reside. The services and the service communication can be in cluster or they can be across cluster. So we can see shopping and catalog here. So it doesn't matter. Catalog could be on this cluster, catalog, shopping can be in that cluster. It doesn't matter. We can move our services across clusters. We can add additional services. The policy will be enforced irrespective of where that service reside, on what cluster, on what cloud. Now let's take a look at a specific policy here, and we're going to look at the policy that's basically shopping the catalog. And I'm going to go ahead and edit this policy, and we can see that the source for this policy is shopping, the destination is catalog, and I'm going to go ahead and deny this policy. Now, by doing so, you can see automatically that the policy has now been enforced, and I have an explicit deny between shopping and catalog. And again, this is going across clouds, across clusters. And I made one policy change, but it's applied in 2 places because I have 2 instances of shopping. So you can see how by using the services construct with Tanzu Service Mesh, we can apply a policy irrespective of where that policy irrespective of where those services reside, and irrespective of how many of those services we have distributed across our clusters. Now, if we go back into our application, this may take a little while to apply, but if we start to refresh here, yes, we can see now that our catalog is no longer showing up because we've denied that communication. So you can see with Tanzu Service Mesh, very simply with access control policies, we can easily achieve a zero trust model with our distributed multi-cloud application.
Wow, this is really a impressive proof point for VMware's engineering DNA to abstract complexity, right?
Absolutely.
Before the demo, we just talked about taking a monolith application and breaking it apart, and then visually we just saw that in the demo, different pieces. One thing we didn't touch on as yet another kind of layer is breaking it into multiple instances. So it's like this additional layer. And then in that demo, the ability to shut down a specific service or the access between two of them, and it applies to multiple instances. So super important. I don't know if there's other parts you want to point out from that demo.
Yeah, I think the important part there is, there are mechanisms to do that in a single cluster. But when we start to look at this application that's now distributed across multiple clusters, across multiple clouds, starts to become a little bit more complicated. And this construct that is unique to Tanzu Service Mesh called the global namespace allows us to easily achieve this.
And that global namespace is as it sounds like, right? It doesn't matter what cloud it's in or if it's on-prem. If you want to deny that in that service, the access to it, then it does it within the context of that global namespace, correct?
Absolutely. So those clusters can be on-prem, clusters can be on cloud, they can be anywhere. Once they're under this global namespace construct, the mesh is intelligent enough to know, the different services that make up the application, the amount of instances that make up the application, and once you apply that policy, it knows how to enforce it.
And this was mentioned in the video, but is this a heavy lift to get this type of visualization into the code so that Tanzu Service Mesh can create that? Or how does that happen?
Yeah, I mean, no changes to the code. That's the beautiful aspect of it. Once you install the mesh in the cluster, it's just transparent. We, at that point, start to observe the traffic and make these decisions. So programmers don't have to set up MTLS encryption, nor do they have to change any aspects of their code in order to realize this capability.
Yeah. Again, the abstraction of that complexity is hugely important, especially to operate it at scale, right? This is just one application, but
Right.
you've got tens, hundreds, right?
Yes.
Or have inherited, right? Those from another company or an acquisition. Then this may, being able to understand what's going on is super important.
Absolutely.
So that east-west traffic that we're protecting between the different resources, we're going to go one layer deeper. Now we're going to look at, all right, yes, these two resources are allowed to talk to each other, so we can specify that. Now, is what they're saying to each other or transmitting to each other actually allowed? And that's another layer of security. So let's go ahead or do you want to preface anything else before we roll the demo?
Yeah, absolutely. So that's important, right? It's just not, what service can communicate with what other service, but what are they able to pass to one another, right? In some aspects, we're dealing with sensitive information, and we want to lock down our application to specify what services, and not just what services, but what particular API endpoints on those services are allowed to see sensitive data like credit card information, right? And this really helps in kind of locking down our application and making sure that services that are not supposed to be seeing sensitive information automatically get blocked if sensitive information is being sent there, also to protect us from any exfiltration attempts as well.
Yeah, the analogy I think of is from the Super Bowl, right? So, okay, everybody's transmitting information from the Super Bowl, right? They're actually showing it all. But then when something comes on there, an interview or whatever, if there is language that should not be transmitted to that audience, that is an additional layer of protection, right? Same thing here between these resources.
Yep. Good.
All right, let's take a look at the demo.
Look at how TSM can be leveraged to secure our sensitive data that may be traversing our application, like credit card information, and how we can create API level policies to protect that data. So to kick things off, I'm going to go ahead and and create some traffic on our application by adding some items to the cart and checking them out. So let's go through the process here to check out this item that I just added to the cart. I'm going to go ahead and enter in a credit card pattern there and check and place this order. Check this out and place this order. So our order has now been filled, and Tanzu Service Mesh is observed that information. So if I switch over to PII here, we can see now that Tanzu Service Mesh has seen PII data enter in the application, and we see how that PII data is traversing the application. So data entered into the app, into shopping then forwarded it to order, and then order forwarded it to payment. And again, this is a cross-cluster, cross-cloud communication here, and we are detecting all this information. Now, what we'd like to do is we'd like to really use API security to lock down our application so that only shopping, order, and payment should see PII data, but not just the service itself, but particular API endpoints on that particular service. So if I drill down into payment as an example, we automatically detect the API calls. And you can see here that API endpoint pay is where we've seen that credit card information. If I drill down into shopping, we should see the API endpoint there as well. So we see all the APIs that have been detected. And if we go through this list, we can see here there's another API endpoint that we've seen, or we've seen credit card information. So what we want to do now is we want to create API security policies that basically really lock down our application and only allow those particular API endpoints to see credit card information. So if you look here, we've created a series of API security policies on our services. And by default, what we're saying is we're denying all API data. So if we're seeing any API data on any of these services, we deny them. However, if we look at, let's drill down into shopping as an example. If we look at shopping, we have the same, right? We're going to deny PII data on all the API calls. However, we're going to make an exception. We're going to make an exception on this particular API endpoint. And if I look at this a little bit deeper, we see that we've added a policy that says, allow credit card information for this API endpoint. Now, what I'm going to do is, as part of the demo, is deny this. And I'm going to put a 402 here. And we're going to go through our app again and submit an order. So let's add this to the cart. And let's check this item out. So go through the same process. Put on our credit card information. And try to place our order. And we see now we get an error. And that's because TSM now has denied that request because we've explicitly changed the policy. Now, if I go back into my global namespace and take a look at my shopping service, and that is primarily that particular API endpoint, I can get some further detail. So I can see that what geo that PII data came from. Again, I'm situated here in Toronto, Canada, so you can see that PII data came in from Toronto, Canada. I can also detect the type of PII data. So you got some nice charts here that give you some deep information. We can also look into the API logs as well, and we can see that we made that request. We see that credit card information, but now we are denying with the 402. So this shows you how TSM can really help lock down your multi-cloud distributed application, leveraging API security, and really protect your most sensitive data and make sure that sensitive data is only seen on the particular API endpoints that you allow.
Again, super impressive. I want to take that example and apply it to a customer, a real life kind of customer need. And I'm going to kind of do this as a thought exercise with you, Rick, where the customer has already got, right, an existing pretty complex application. Numerous developers are working on it. Some of these developers, like any organization, there's attrition. And so some are moving in and moving out. And this is where the security folks that are watching should perk their ears up, because the ability to protect against bad actors, right? So this is an internal bad actor. Of course, nobody wants them, but unfortunately, in the world we live in, there's just a percentage of the population where this will actually occur.
Yeah.
And if they know and understand the topology of the application, then there is potential for them to use allowed paths very cleverly to take information out. So is that something that you've seen, or go ahead?
Yeah, absolutely. And this is why it's important not only to protect our applications from a north-south standpoint. I mean, there exists, API gateways that can do that from a north-south standpoint. But more importantly, to your example, is we also need to protect our application east-west, the internals of the application, even though some of those services are not exposed northbound of our application. But, to that point, right, we need to achieve a zero trust model. Zero trust model is the model that we should all try to achieve. And, specifically Tanzu Service Mesh helps us achieve that in this new modern world, and specifically, applications that are spanning, multiple clouds.
Yeah. Let me ask you this question. When we talk about zero trust, certainly, that's a topic that's been around for a while, and people define it in different ways. I think about the zero trust and limiting the amount of resources that are available to a resource should only be able to use what it's entitled to, right? Or what's specifically specified. The layer of zero trust that then deals with the data that is transmitted, like PII, is that another layer? Is that another kind of a further ring that is put upon, I guess, that zero trust model? Or how does that get described?
Yeah, I mean, it's part of the same, context. It's just that we're able now to, outside of just say who can communicate to one another, which is, let's say, where, zero trust kind of started off, right? Is like this service can only talk to that service. We're also, analyzing, the traffic, right? And getting in a little bit more depth to say, not only can this service speak to this service, but, you can pass PI data, but from this service to that service, yeah, you can communicate, but if you're passing PI data, we're going to disallow it, right? So we're just kind of making that zero trust model that much stronger.
So a bit of an evolution of it. Okay.
Correct.
All right. Fantastic. Okay. Then moving into our last demo of the show, before we get to the Q&A, we're going to look at how Tanzu Service Mesh can actually assist with threat detection. So any preface to what we're going to see?
Yeah. So outside of creating policies, we can also, detect threats. And so what we're going to see in the next demo is, a threat detection, a SQL injection, and how, we're able to get some kind of rich information, around that, that attack. And again, that attack is happening at a particular API endpoint, right? So it's just not, at this application at this IP address, is we're kind of honing in and saying, this particular service at this particular API endpoint is being attacked, and we can look at the signature of that attack.
All right, fantastic. Let's take a look.
So Tanzu Service Mesh not only can protect your services in APIs through access control and API security, we can also detect threats and attempted attacks on your particular application. So if we switch over here to attacks, we can see there's been an attempt attack on our shopping service. Hovering over here, I can see the attack type is a SQL injection. So if we dive a little bit deeper and take a look at the service, and move over here to service analytics, we can see that this particular attack happened within the last hour. I'm looking at a window from the last hour, and we have the security event listed here. We're going to dive into that in a little bit deeper in a few seconds here, but kind of wanted to show you again, looking at these rich charts, we also see geos under attack. So we actually see the geolocation in which this attack was attempted. And again, I'm based out of Toronto, Canada, so we can see the region here that I attempted this attack. Now, if I pull this down from the last hour, and let's take a look at, for example, the last 15 days, we see a lot more events, right? And so we're seeing the events for the last 15 days. And again, going back to this chart, this should then reflect all the other geos as well in which we've seen attempted attacks. Now let's go back to the last hour and take a look at that particular event that happened within the last hour. So if I dive a little bit deeper here, I can see that the attack was attempted on the API endpoint products. So let's take a look at products in a little bit more detail. So we are going to go hone in on the products endpoint and take a look at its logs, and we can see now those SQL injection attempts on that particular API endpoint. We can then expand and get a lot richer information on that particular attack. Specifically, again, the geo, we can see where that's coming from. And we can also look at the attack details and actually look at the signature. So again, Tanzu Service Mesh not only can protect our APIs, but can also give us some good insight when there are particular attempts at attacking and infiltrating our application.
And the abstraction to be able to see the topology, no matter where the services reside, and then notification of the specific location, super impressive and super valuable.
Yeah, absolutely. And again, that signature as well, to be able to, to see that signature on that particular and the particular API endpoint starts to become valuable, right, from a threat detection standpoint.
Yeah. Rick, before Tanzu Service Mesh, how were customers kind of handling this? What would be their process?
I mean, there are other tools that that folks would leverage, but it just becomes a lot more complex when you're dealing with a microservices architecture, right? The level of complexity is many times more complex. And so, therefore, something like a service mesh that is, I would say, very API centric and allows us to observe things from that lens, allows us to, to really, achieve the level of security that we're wanting to achieve in this new modern world.
Yeah. I think in many cases where we're, utilizing VMware cross-cloud services, one of the overarching themes is time to value, right?
Right.
So when you're trying to resolve something and there is the opportunity to use a tool to resolve it faster, right? To
Yeah.
abstract that complexity, it's a quicker time to value to resolution. You can move on to the next thing, right? That you can determine that threat, fix it, mitigate it, remediate it, whatever it may be, and move on. And if you do that in 15 minutes, maybe that's a bit of a stretch, but versus 15 hours, that's a big difference, especially if it's a mission critical system.
Yeah, and some of the things we're looking at is, as you saw there, we got some rich information. Some of the things that we're looking at is integrating, some of these threat detections right into a development environment like Visual Studio Code, because some developer owns, that code, and to be able to alert a developer to say, look, this particular API endpoint that you own and you're working on, it's being attacked in this way. Let's look at that attack in a little bit more depth to see if there's actually a vulnerability here, right? So again, time to value, time to resolution.
Mm-hmm. Fantastic. All right. I know there's been a pretty active chat. I was monitoring it a bit on the side of my screen here. So I'd like to welcome back Leanne, or actually, sorry, I'd like to welcome to the show Leanne, but welcome back Jyoti also. Leanne is going to help us. She's been manning the Q&A, and she's going to surface some of the questions that have come up during this live stream.
Yeah, and actually we've had some great conversations going. So thank you everybody who has been asking questions. We've been trying to answer a couple of them just in the text as we go, because we're not going to be able to get to everything today. So one thing just kind of quickly that came up, we're talking about specifically Azure earlier, and around guardrails and just some of the Aria solutions. So just kind of, want to make sure that we're calling out that we do support more than just Azure. So I don't know, Jyoti or Alexander, if you want to kind of comment on the broader support.
Jyoti, I'll let you go for it.
Yeah, so I can add here. So for now, like across different products in the Aria portfolio, we are supporting all public clouds, which is AWS, Azure, GCP, and also supporting Kubernetes. For Aria Automation for secure clouds, we are also having some advanced detection rules to find misconfigurations between the cloud resources and the Kubernetes clusters as well. So we have a wide range of support in terms of breadth.
Perfect. Yeah, and I obviously I knew that, but I wanted to make sure that we called that out. So, yeah, and so kind of sticking along those same lines, we also did get quite a few questions about being able to test policies before deploying them. Being able to maybe extend a base policy, things like that. And I know there's a lot more that we can do around there.
Yeah, so on the question about applying base policies, so Guardrails allows you to apply multiple templates against the account. So it can be a combination of baseline templates that are applied to all accounts, plus any additional templates at a per account level. So you can apply multiple templates, so that helps as well. And in order to test, we recommend that you can build a template and test it on a policy staging account or some environment in testing to see what the policy can find. And again, that's one great way to ensure that you're also testing out these policies before you're handing over the accounts.
These are great operationalization questions, right? One thing that VMware knows how to do really well is not just to make the software, right? Of course, a lot of the infrastructure, but then to make sure that infrastructure can run at scale, right? And this is what we've been doing for the past 25 years. And now we're evolving that into the cloud to help our customers run these applications at scale in multiple clouds.
Yeah. Perfect. So kind of switching gears a little bit here, Rick, we actually did have quite a few questions that our counterpart, Bob Bauer, thank you very much, has been answering some of this stuff over text. But just kind of wanted to see, do you want to talk a little bit more about if we have mechanisms to be able to automate the creation and the management of service mesh security policies? Yeah. That kind of ties into some of the things that have come up.
Yeah, a great question. So, I mean, obviously you saw the demos again. We looked at our console, but we also have a declarative API that you can leverage to instantiate all your policies and the global namespace as an example, right? So it's a great methodology, a great way to kind of leverage, a GitOps process if you're, interested, obviously, in doing so. And obviously, a lot of customers these days are looking at leveraging GitOps in a declarative model. So definitely, we have a way to automate all that you saw there through a declarative API.
Perfect. And there were some questions that came up about around being able, how much was CLI and GUI and everything. So I answered some of that just via the text, but we definitely understand that there's a lot of interest in being able to do things through APIs, and that's definitely a focus. So I think, yeah, and so there are a bunch of other questions that have been a bunch of other information that's been provided. But one thing that I think is also of interest, then, Jyoti, is how can people get started specifically with like Aria Automation for secure cloud? It's like, where do people go next? Because there's a lot of options out there for them to start learning.
Yeah, sure. So currently, we have a VMware Aria Hub free tier offering. So this is a multi-cloud management platform which is integrated with VMware Aria Automation for secure clouds as well. So it integrates, in fact, across the VMware Aria portfolio. So specifically for secure clouds, what you can do is that you can sign up for free for this free tier offering, and you can benchmark compliance with the built-in CIS frameworks and also track the progress of application of these, detection of these violations, and also you can track how you're resolving these violations. So it's a good one to actually go sign up for and get some hands-on experience on the platform.
Great. Perfect. And I think, Alexander, you probably have some call to actions. It looks like one more question just came in, so I'm going to kind of put you on the spot here a little bit here, Rick. But in kind of talking about some of that zero trust philosophy, one of the last kind of questions that just came in here is, who are some of these tools? And this might actually be a question for both of you. Who are these tools more intended for? Is this more for a securities team or a platform team in order to kind of implement and really kind of manage the zero trust?
Sure. Yeah. So I would say from a Tanzu Service Mesh, we're looking at the application architect, right? Would look at and leverage these tools, right, to secure their application in conjunction with with security teams, right? So I would say it'd be the application architect alongside with security that would basically leverage TSM to achieve that zero trust on your multi-cloud app.
Perfect. Perfect.
So let me ask you, let me pull on that thread a little bit, Rick, because you've got the application architect that should know how all these things interact, and they kind of set those policies, right?
Yeah.
Of course, they're not going to be the ones that are constantly enforcing it. So there's really, then it's a handoff, right, to the security people to make sure that things don't go awry, so to speak.
Yeah, correct. So it's both of them kind of working in conjunction, right? The application architect should know how all the different components are communicating with one another. But Tanzu Service Mesh helps us actually see how that communication, we discover the APIs and we see how that communication is happening across your application. And then, given that discovery, we can then go ahead and apply that policy, create that policy in leveraging a declarative methodology and check in those policies into Git.
In the perfect world, we would start with that application architect. They define the security policies between the different resources. Have we also seen it where it's not a perfect world, and here's this application that's already been created? Can we drop Tanzu Service Mesh in there and kind of go backwards, so to speak, to clean things up?
Yeah, we can obviously detect, and we can also do schema validation as well, right? So that even though, let's say, someone's maybe created an new API endpoint and it needs further scrutiny, we can put in a schema validation to validate that the schema and how that API call how that API is being called adheres to the schema that is allowed and vetted.
That's good.
Perfect. That's outstanding. So I think we've tied off on most of them. Jyoti just provided me the link to be able to sign up for the free tier of Secure Cloud. So I'm gonna put that out there right now. And just kind of another call out. I did say this in the comments earlier. The recording for this will be available as soon as we wrap up today, but we will also be putting it on YouTube. So Alexander, I guess I maybe can send it back over to you to kind of do some final thoughts and wrap up.
Fantastic. Well, it's been a super exciting episode. Jyoti, very much appreciate your participation as well as your thoughts as a subject matter expert in all things governing the entire governance lifecycle inside the multi-cloud environment. Rick, your expertise in application security, super helpful too. So thank you both for joining today. And with that, I'll go ahead and wrap up. And thank you, Leanne, for fielding the questions over there. So we want to pop that last slide up. Recapping what we covered today. Number one, thinking about that full governance lifecycle across the multi-cloud environment. Not easy, but possible to do it right. Point by point by point cloud, But the second you get two, three, 4 clouds, which most customers are actually in, and again, we define those clouds as being anything from on-prem to a hyperscaler to a private cloud to a sovereign cloud. All of these things are coming together to enable businesses to be able to tackle and get to their business outcomes. So you want to make that simpler, going back to time to value, reducing the amount of overhead and the complexity to make it easier to govern inside of that environment. From there, we went over to threat detection in that particular environment when there's what looks like a bad actor inside of an organization, and then they are turning off logging, right? And how do you investigate? What forensics are available? How do you find and break through that complexity when it's happening in all different environments, different clouds? Then moved on and wrapped up with modern application security, taking that monolith application, breaking it up so that you can get the benefits of microservices, and what comes with those benefits, really, that security, or figuring out how to secure the communication between those. And we went into depth there. So that was a recap of episode number 3. Hope everybody got value from it. Want to do a quick call out to follow VMware, because when you follow VMware, you'll be notified when these episodes happen, as well as the next episode, which will be coming up. Right now, it's planned for May 10th. So join us on May 10th. Also, you can scan that QR code, which will point you to our blog. And from there, you'll be able to get the show notes, which will be produced in just a few days and be available. Thank you, everyone, for joining. Thank you to our guest speakers. And thank you to also the other subject matter experts who were behind the scenes working on this, as well as providing demonstrations. Until the next episode, take care. Have a great day.